Hello and welcome to the Sub1 YouTube channel. My name is Ray, and in this video, part 5 of SpotMicro, we're going to start putting the body back together with most of the electronics having been done and get ready to install the legs. So where I left off in the last video, I had run the power wires back to just a pair of wires to input the 5 volts on. We've got the spare wire that goes to the LCD display in the back, and in the front part we've got a ribbon to the 2 ultrasonic sensors which plugs onto the Arduino. Okay, so the first thing we need to do is poke our wires through. And that looks alright. Now, this is going to be a fun one to try and mount. Just grab a drill. Now it is easier to drill it this way up. I might just do that. Rearrange the way my spaces are. Okay, so those screws haven't got a prayer in making it all the way through that thick bit of plastic. So I'm going to drill a slightly larger hole for the head to go into and embed the screw in. Now these screws are an M2.5. The hole I drilled is a 2.5mm hole, and I'm going to use a 4mm hole for the countersink to embed that screw in. And it would seem 4mm is not big enough. I haven't gone quite deep enough. Yes, you can see the screw just poking through, and that should be enough. Maybe it's not enough. That works. So I can do the same with the other one now. So that's our first one. I might just put a hole through in around this area where this little adjustment screw is. Now while the servos are not overly sensitive on their voltage, they've got a fairly large range which I can preset. The Raspberry Pi is very sensitive to its voltage, and I typically set it to 5.1 to prevent that under voltage alert coming up. So I want to be able to get in and tweak that with a little screwdriver like this one. So for that we will need to drill a hole through, in order to get the screwdriver through to be able to adjust it. So let's just mark that. And that I do want a smaller hole. Just slide that out of the way so I don't accidentally drill into it. Now I am running this drill on low speed, drilling into plastic. You don't need to rush this. Rushing it's a good way of ruining your part and damaging other parts, getting yourself into real trouble. Yep, that works well. Probably could have come back towards the back of the robot a little bit further, and I can open it up a little bit. Yep, that works. So that allows me to do a little tweaking on it if I need to while it's assembled. Now before I screw this in finally, I do need to attach the wires to it. But before I do that, I do want to set the voltage on these. So the one for the... I just want to check the standoff height. Probably not quite enough. I might grab my standoff set and swap them around. I will note what size I end up using on this in the description. So I might just go and try and find those and find the right size standoffs to use. I'll be back in a minute. Okay, for standoffs, I've gone with two different sizes. I did want some clearance between these two boards, so there was no chance that that potentiometer screw, the metal screw, could touch the bottom of the other board. If they were to touch, it would be bad. The top one connected to here obviously is going up against plastic, so if it makes a slight bit of contact, it's not going to be, you know, dramatically problematic. Okay, so the top one, I've gone with a 12mm long standoff, but for the bottom one, I went with a 15mm long standoff. These are 2.5mm threads, just so you're aware. Okay, so first part was to find the right standoffs. We've got our screw holes all set up. Next thing is to set the voltage on these, and the way you do that, get yourself a power supply or your battery. I'm using a bench power supply that came with my soldering station. It maxes out at 15 volts, but I can set it for the 7.4 volt output that our batteries will be running at. For this you will need a multimeter, which we will set to DC volts. Now this set of leads is actually a very cheap category 1, I think they are, so don't use them for any sort of high voltage, but they've got these alligator clips on the end, very configurable, very handy at times for this low voltage stuff. So if I turn on my power supply, which I've got set for 7.4 volts, this one's tuned, so this is the upper one, for 5.11 volts, which is going to be ideal for the Raspberry Pi. Now I've actually already adjusted this one. By default these things are set at 12 volts. So if you've got a greater than 12 volt supply, then you will get 12 volts out. That's one. And our second one, we want this one set for 6 volts or thereabouts. That's the maximum voltage rating on our servos. And I've adjusted this one to 6 volts. So with those two set, and with these you turn them anti-clockwise to drop the voltage and clockwise to raise the voltage. They are a 10-turn multi-turn pot, so they will turn times from one end to the other. Okay. So our next trick is to start putting some wires onto these. Let me just grab the other colour wires. Alright, so in the industrial electrical world, blue-brown are commonly used for positive and 0 volt. So I'm going to use those two colours for the incoming power. So these won't have to be overly long, they just need to get through the back housing. Okay, next we've got our wires going to the servo board. These again won't need to be very long. So the last set of wires we need to connect up are the power wires for the control system, for the electronics. Just move that wire out of the way. Okay, so with this I'm going to end up poking a fair bit of wire back. That gives me room to pull things out if I need to. And when you hook these up, make sure you hook them up the right way round, otherwise smoke will come out. And smoking is a bad habit for electronics, they generally don't do it for very long. Okay, so that's our power supplies. These can just be tucked in around here. I will get some cable management to help keep that in place. So cable management can be done in a number of ways. I've got some small spiral wrap I'll use in there, and I'll use that on the servos as well to help keep that under control. Okay, one more thing I want to do before we put legs on is sort out the battery power. So we've got our switch mode power supplies. On the underside I've rotated batteries round the other way. Now these connectors can fit on top under the cover. There's very little room at the back end here for the connectors to go into. It's very tight. There's provision for a cable tie so I can run a wire through there and actually tie it into place. So that's what I think I will do. So for that I've got these connectors that plug into these two batteries. Now these are a male connector and exposes the pins, and this is female, so while there's nothing plugged in, it's reasonably safe. You're not going to accidentally short it. But if I connect two wires just up in parallel to come through, as soon as you plug one in, the other one exposes. Granted, it's only 7.4 volts, but if you short it to something metal, there's a lot of potential energy in the battery at 7.4 volts. So to prevent shorts from becoming an issue, I'm going to use a device. This semiconductor is actually a dual diode, so there's two diodes in it, with the output of the diode being the middle pin. So we can feed the two red wires, our positives, one to each side, and have the output out. That way, if I've got one plugged in and the other one not, and I accidentally short this, it can't short, like it can't blow up. It means that I have to charge each battery independently. That I'm not worried about. So what we're going to do is probably mount this, and I'll probably mount it on the inside. So for that, I'm going to need a couple of bit of short bits of wire. And what I'll do is I'll connect the connector up to one, bring it back into here, put a bit of a loop in, bring the positive wire onto one of these, make a very short one, join the two negatives together in here, and put the other positive on, and then bring the wires back out this way. Let's get into that. So this terminal is our positive one. Might just grab some bigger heat shrink. So this wire has a black trace on one side. I'm going to put that on the negative. That number of it later and put it in the descriptions. And the middle one is the one that goes out to the rest of the controller and our power supplies. It doesn't matter which battery goes onto which terminal. So I'm just going to connect this one onto this one. What I think I'll do next is get a small self tapper and just put it through there. It'll have to be a very short one just to hold that in place, and I'll get a small cable tie and put around there. And now that's done, these two wires will run up there is room for the connector to sit on top of the batteries, so, and the cover go on, so we'll do that. But I won't hook the batteries up until after the legs are on. I've got to put the legs on before I put the back cover on, and the switch is in the back cover, so this will go to the switch. Right, that'll do for this video anyway. If you like these videos, don't forget to click on like, subscribe, ring that notification bell so you know when other videos coming up. Don't forget to leave a comment if you've got any questions or any suggestions. I do read all my comments, and it's also a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to help the channel further, I do have a Patreon account. There is a link in the description, and you can join my VIP members, Go Lucky and Lorenz Berger, my other members, Morales45 and Ratchet. There's also a Discord server where you can join the growing community of builders working on their robots and designs. And we'll see you in the next video.